One of the interesting things about our reality that you can think about is that our reality at its most basic chemicals or mathematical structure is a solute and a solvent, or several solutes and several solvents. And you can think of it in as far as matter as the thing that is being dissolved, and the space and time is essentially the liquid that you've got. And so it's a context and a content as far as the information that exists within that solution. And so it's like the universe is like a glass of sugar water when it's evenly distributed at an equilibrium, and there's no distribution of mass or space. But what tends to happen at a state of equilibrium or rest is, due to the difference in density between space and matter, is that you get sediment. And so our universe is actually less like salt or sugar water, and more so like a salad that you would buy at Wendy's, or not Wendy's, but a restaurant or fast food. But Wendy's got pretty good salads. But the entire idea is that is the simplest basic structure of the projective plane in which we live. So when you can also think of it like there are physical solutions and solvents and solutes, and there are chemical reactions. And so there are physical changes and chemical reactions that are happening throughout the asymmetrically distributed existence we live in. And so matter is asymmetrically distributed, which means that it doesn't have it's not symmetrical. It doesn't have that even quality. It's kind of like chirality, the principle of chirality, that one side of a molecule is not the same as the other. So what one of the ways I like to think about the universe or the reality that we live in as a whole is that all the chemical reactions and distributions of mass and energy and space and time, they culminate to a visceral type reaction. So our universe, or volatile is the right word. Our universe is volatile and asymmetrical as far as the distribution of space, time, and mass or matter. And so you can think of particles, particle physics, as just being the study of the different types of sugar, or the different types of granules of what is dissolved in the liquid that is space-time, or the memory slots, or the voxels of that projective plane. So the whole idea is that those chemical reactions will eventually reach a state of equilibrium, and once they do, they'll be at absolute zero or below. And that's the thing, is what if a chemical reaction or a physical reaction was going to happen for an infinite amount of time? We would never know when it was going to halt, but we would know then that we had computed what exists. But the universe had computed itself and reached a solution or a halting or stopping point. A halt is actually different than a stop by definition, whereas a halt is something that stops for a short period, a temporary amount of time, just discrete, whereas a stop is a permanent halt. So those are the basic definitions or ideas in biology. So I like to think about the multiverse as being voxels that are like if you had empty boxes, or could be spheres. So if you imagine that you have goldfish bowls, and those goldfish bowls are evenly distributed throughout space, but they contain asymmetrical solutions or distributions of matter in space, in the space inside those bowls. And we can think of the Earth or people as, such as an astronaut, who's as being like a goldfish, similar to Alice, as Leonard Susskins said in his lectures. And so I don't know if you disagree with me or not, but it's the idea that came to my head was that if you were to upset the system, you could upset critical mass by adding an astronaut from one multiverse or universe or whatever, or parallel universe to another. It would be due to the effects of gravity, but there's also, you can think of everything as having a centrifugal force and a magnetic, it all exists on a magnetic plane, electromagnetic or photovoltaic plane. And so that's actually statics, like what I forget her name, what she did, but it's the study of statics. Is it you can think of it like iron filings when you move forces around and stuff. So everything is kind of just moving, and it's but these are just my thoughts on the idea that the universe is a mixture. And a mixture is divided asymmetrically. There's clumps and stuff, and there's not an even distribution like there is with sugar water. And so that's what the universe is trying to compute. It's trying to compute the mixture of what it is into an even distribution of particles that is within a set number of overlapping fields. And so those fields go on supposedly for an infinite amount of time, but there's warps in those fields, and there's not tears, and we know that there's not tears because black holes have entropy. So space-time does not have tears in it. We also know that because space-time has our reality has laws of conservation in chemistry and physics. And you can't have laws are universal is the assumption, but we don't know how far localized events in our reality here on Earth are, how far they extend, but there are localized effects of forces and materials in different physical distributions and changes and chemical reactions. But there are also general effects that affect the entire projective plane of where we live, our whole reality, in general, the multiverse. And so one of the things about Alice is that the goldfish is that if we imagine that there's a goldfish in every single bowl out of all those infinite goldfish bowls that are voxels, those those goldfish are identical in some bowls, and in others they're like snowflakes, where they're all different. And so there are similarities or between some, but they are all have a quantum signature or an exact number assigned to them that is individual to that specific existing thing. And so if we were to travel outside of our cosmos, we might cause a change in the centrifugal force or within the system as a whole, and all those goldfish are like collapsing off of a shelf into whatever the gravitational singularity is. And so it's an interesting concept, but how do you travel from one multiverse to another without collapsing all those goldfish bowls? So the answer that I came up with is that because you can't delete data, you could take Alice and you could actually switch her at the same rate between one goldfish bowl and another through the entire time that she's traveling, rather than ending up and you would have to simultaneously switch two goldfish at the same time in order to end up in another reality or another universe within the multiverse. And so that's an interesting idea. You would have to get through the cosmic horizon or the cosmic firewall that exists. So you'd probably burn up before you would leave our cosmos or our goldfish bowl. But Alice is gonna we're gonna pretend that we can get past that problem, the firewall problem. It's an interesting idea, but the question is are those goldfish bowl actually identical or different? And I think they're different because one of the things is that we can conceptualize the idea of that our universe is asymmetrical due to the well, you just have to look around you. I mean, if things were evenly distributed, it'd just be a homomorphism within the field. So it'd be a lack of change. Everything would be the same object or idea or concept. It's mind-boggling, but it's interesting.